Good morning. In today's video, we are going to talk about usability testing as a way to conduct user evaluation. Before going into detail of usability testing, let's have a recap of the goal of evaluation. You have already met these slides when we talk about the heuristic evaluation, but still this is a part of the evaluation. So what is evaluation? Just a reminder, evaluation tests the usability, functionality, and acceptability of an interactive system according to various things, various stages of design, various goals, various dimensions, and using a variety of techniques. But the idea, as for the introduction that we have seen in the heuristic evaluation, is to identify and correct problem as soon as possible and possibly in an iterative way. We have said that evaluation can take place in different places, like in the lab, in the field, so in the real world, and it could involve users in different way, like for observational methods, like the observation, the interviews that we have already seen, or query methods as well, but also with experimental method. And also could be based on expert evaluation, like the heuristic evaluation we have done, and also automated, more software related, and that is especially good for low-level issues. We have done, as you know, the expert evaluation already, so the heuristic evaluation. The heuristic evaluation, or in general an expert method, is typically quite fast, 1 to 2 hours per evaluator according to the different kind of devices, prototype, interface you are going to use. Results are pre-interpreted because the evaluator are of course expert, so they give you an interpreted result according to some heuristics, some guidelines, some knowledge that they have. Heuristic evaluation, however, could generate false positive and can also might miss some problem according to the kind of evaluation. But as we have done, heuristic evaluation or other expert method are actually useful for filtering and refining the design. And in our case, applying it to the paper prototype allowed us to identify quickly, in a way, the major design issues, so that moving on with our prototype, for instance in software, those major issues are solved. On the other side, we don't have the expert methods, but we have the user studies, like usability testing, that is the goal of today's video's lecture. And usability testing and user studies involve people, the users, so not expert, but the users of your system, the target population that we identified at the beginning of the course for need finding. For user studies, you need to develop the software or prepare the setup to conduct them. Such kind of study are in general more accurate for your target population because you are going to use and you are going to involve actual user and the task they are going to do in the system as expected by design. User studies, differently from expert method, tends to occur in the later stages of development, however. And since at this point in the course we are in one of these later stages, it's a good moment to start talking about usability testing as well. Usability testing is an evaluation not done in the field, but done in the lab. Again, just a recap, evaluation done in the lab have some advantages. The environment is controlled, is uninterrupted because you define the task, you define what people need to do. You can have specific equipment available and ready to use. You want to video record, you can have a camera and a fixed camera in a position, etc. It also has some disadvantages, like the lack of context. Of course, you are in a room. So if you want to test something for, I don't know, a mobile application for navigating into the city, you of course cannot have the navigation into the city because you are in a lab, you are in a room. And it's also difficult to observe several users cooperating with this kind of evaluation. This kind of evaluation is typically done one-to-one. So it's difficult to have people cooperating and running an evaluation together. Evaluation in the lab, however, are appropriate also if the system location is dangerous or impractical, or for constrained single-user system for a good amount of manipulation of use that is controlled by you. So, user studies are experimental methods that involve users. And we have two major categories of them. We have the one that we're going to talk about in this video lecture, that are usability or user testing, called in both ways. And the idea of usability user testing is the one reported in the slide. Let's find someone to use our application so that we will get some feedback on how to improve it. So it's mostly anecdotal and is mostly observation driven. You give your application to someone, you give the task to someone, and you look how they behave with the task, and so you can observe and you can collect some measure, some anecdote, and then apply them to a further iteration to improve your application, your system, whatever. On the other side of experimental methods, we have controlled experiment. Controlled experiment are more scientific, are more hypothesis driven, and are not part also of what we're going to cover in this course. But a control experiment is another kind of experimental methods that involve user, and different from usability testing. That is, again, let's find someone to use the app and get some feedback. Control experiments are more on the line of we want to verify if the users of our application perform a specific task faster, with fewer errors, with some other specific measure, specific goal than our competitor's app, or than another version of the app, or than a previous version of the app. So you want to measure in a very specific way some very specific attribute between two versions of an application. Two versions of the same application, or two applications that does the same things. Like I want to compare, I don't know, if navigating with Google Maps is faster or with fewer errors than navigating with Google Maps. So this could be one kind of simple control experiment, but it's scientific and is an hypothesis that creates the entire experiment and drive the results of the verification. As I was saying, we won't talk about control experiment, but we will talk only about usability testing in this course and in this lecture in particular. So what's the goal of usability testing? The goal of usability testing is threefold. First, usability testing is a way, as many other evaluation methods, to identify problem in the design of a system, but also to uncover opportunity to improve the same design so that you can iterate and create a better application in some way. And a third goal is to learn more about your target user, their behavior and preferences, not in general, not about a specific domain or a specific set of activities, but with your application and device and system. So what's the definition of usability testing? And the definition will give us some specific term that we are going to see again in the remaining of this lecture. The definition by the Nielsen-Norman group is that in a usability testing session, so within usability testing we have sessions, you have one or more session, one session per participant. So if you have 10 participants, you will have 10 sessions in a single usability testing, in a single study. In a usability testing session, you have a facilitator, also called moderator, that asks a single participant to perform a series of tasks, usually using one or more specific user interface. In this case, it could be an application, could be an interactive system, whatever. So, ingredients, we have session, where we have one facilitator, one participant, and a set of tasks using one or more application systems. And so the facilitator will be you, in a way. the one that moderates, the one that facilitates the session and help participants navigate the entire session and the entire testing. Then you have one participant that should be from your target user group that will perform some task decided beforehand by the researcher, by the designer, by the developer, in tasks that will cover the entire application or the part of the application of the system that you want to explore and you want to get feedback on. So in this session, you have the participants that perform a task under the guidance of a facilitator. And while the participant completes each task, the facilitator observes the behavior and listen for feedback. So the facilitator is there and see if the task is completed with success, is completed with some errors, is not completed at all. And so he can notice, or she can notice, if all participants don't complete the same task. And so from that, they can learn that maybe the interface that is behind those tasks could have some specific problem more than other part of the application of the system. Usability testing are traditionally done in a usability testing lab that are specific rooms designed to run usability testing. Of course, you can conduct usability testing also not in this room, but these rooms are well kept to run this kind of evaluation. So how it's done, a usability test room? It's a room like this one, and it consists of two areas. You have the testing room, where the participant is using whatever device, whatever application they want to use, they need to use with some task, for instance here on paper, and then you have under a glass that doesn't allow the participant to see what's behind the glass, but allow the tester, the facilitator, to see what's going on in the other room. Behind this glass you have the observation room. So the observation room is where the tester, the facilitator is and observe. In this way you see, for instance here there is a camera that check the participants, and there are screen sharing and other statistics, etc. There is a microphone so the person can talk to the participant in the testing room. And in this kind of lab, the testing room is typically smaller and accommodates a small number of people, typically 1 or 2 people, while the observation room is again using this one-way mirror, and it's larger, and all the facilitator with other people such as the developer that created the product being tested, or other person that help the facilitator to take notes and further observe what's going on in the other room. But you can run, of course, as I was saying, usability testing without a room. You just have to recreate, in a way, the environment that you need. So you need a participant, you need maybe task, you need a device where the participant can operate, and you need, of course, a facilitator that will not be in another part hidden of the room, but will be maybe close to the participant or in front of the participants, according to what you have to test and according to the available space that you have. So these are, let's say, the professional settings, but also can be done without the need of usability testing lab. So usability testing is, let's say, composed by 3 main steps. The first one, that is the most important, is planning. So the usability testing should be planned. Should be planned in terms of who are the participants and what are you going to test, where is the testing happening, and how is the test happening. Are you with recording? Are you recording audio? Are you just observing? There is one facilitator, there was one facilitator and one person that took notes. There is one participant at a time, 2 participants at a time, etc., etc., etc. Which are the tasks? Planning. Planning is fundamental in usability testing, and it's the most probably important most important steps of these 3. The second step, that is still important, is actually running. So calling one participant at a time, over multiple sessions, conducting the test in the room that you in the place that you designated, with the task you designated, with equipment you designated, and with participants belonging to the target population that you define in the planning phase. While running usability testing, the facilitator also collects data about the interactive system and the interface according to what they want to test. And then, of course, there is a third step that is analyze. So once you plan, you run everything. So at that point, you have a lot of data, probably, and both qualitative and quantitative, and you have to analyze and make sense of that data so that you understand and you know how to proceed further, what to apply, when to apply in your application, and what to fix in your application so that you can improve them. So let's start from planning, which again is probably one of the most important of the 3 steps. Planning. Planning has a series of decisions to be made, and I'm going to go through these decisions, but we're also going to apply them on the next class when we are going to do an exercise on usability testing. We are going to devote 3 hours for exercises on usability testing, where we mostly focus on planning the usability testing, because again, it's one of the most important part. So the first things you have to decide is who you will involve in the test. So who are the participants? Who are your target user for your application, for your system, for your product? This is very similar to what we already did for need finding phase. So it's the same who that we ask there, we're going to ask back here. So if you had a very clear target population, it's probably in your case the same that you interviewed. Then the second question is, how many participants do you need? And here there is a short answer and a long answer. The short answer, the very short answer is 5. And then there is a long answer that is actually more close to it depends. So a medium answer, a medium length answer could be 5 is a relatively good number if you have a mostly qualitative and feedback-based usability testing, and if you can run it multiple times over like multiple iterations of the prototype. So having 5 people testing in a qualitative way your system in multiple variation, in multiple version, will give you a good amount of results to continue to improve the system. However, if you need more quantitative data, maybe statistical relevant data, etc., or more robust data, you will probably need 20, 30 participants. So according to the instrument and the tool you're going to use. We're not going to deep dive in this. Just keep in mind that 5 is a sort of magic number, is good enough for a qualitative, exploratory, in a way, usability testing, but as the test becomes more and more quantitative and detailed, etc., this number is likely needs to increase to better represent the population you are going to you're going to use to test your prototype. And I invite you to read the link here so that you can have the details on what I have just very briefly told you. So who are the participants? How many participants do you need? Let's say 5, and then you need to invite these to agree with these 5 people on when and where you're going to meet them and to do what. Then decide which role you're going to play and who plays what role. So of course you need at least one facilitator of the session, and then if you have other people, they can serve as note taker and observer. Typically in usability testing, developer, designers, creator, etc. of interactive system must not serve as facilitators. This is in general. Why? Because developer, design, creator have their own biases, because they created the system, so they will bring the biases as facilitator, especially if they are not expert in facilitating usability testing within the test. So they risk to try to help too much the tester. So this is in general, of course. In our case, in this course, you are running your prototype and you are the developer, design, creators, etc. And so you will need to also serve as facilitator. So we are like violating this bit of a rule, but for a practical and let's say academic purpose. That is that you need to also experiment this role of facilitator, this role of observer, because all of you are the developer, design, creator of the system you created, and there is no one else that you can employ. But let's say in a non-course based system, you are typically going to recruit, to ask someone else that is not so involved in the system to be a facilitator. And developer, designers, etc. can maybe be note taker, can maybe observer, etc. We are doing an exception for, let's say, teaching related purposes. Then, after you selected who and how many and what you do, you have to choose which task you are going to ask your participant to perform. Task may be introduced with a scenario, something like imagine to be in a room that has this characteristic, or you are going to book some flower for a birthday, and then there is the task. So this is a scenario, and then you have the task. Task must be concrete and with a clear goal, and we already have talked a lot about tasks, so try to remember what we said at the beginning of the course. And for usability testing, you have a typical number of tasks between 5 and 10 for a usability testing session. Then, after deciding the task, you have to choose the methodology you're willing to apply, if any. So applying a methodology is not mandatory, but you can decide according to the task, according to the goal that you have, to apply methodology. Methodology are various. Think aloud is a methodology. Cooperative evaluation is another methodology, and I will give you some detail in the coming slide. This methodology is not only you have to choose if you want to apply them, and which one you want to apply, but also for which task you're going to use it. So it makes maybe a lot of sense for one or couple of tasks to use think aloud and not to use any methodology for other tasks. After all this, you also need to define success and failure criteria for each task. So you give a task to the participants, the participant perform the operation according to the task on the user interface, and then you have to decide, you have to have some criteria beforehand that say, okay, what this person has done, what this person did is actually successfully completing the task or not successfully completing the task. And these are criteria you have to define beforehand. Then you also need to decide whether you need or want to ask any additional information. And this information can happen in 3 different moments. This information could be before or after the test, like I want to ask for the age or the experience with some specific domain, something you want to ask before the test, or some information that you want to ask after the test, after the session with the participant. So maybe you want to ask some general, sort of small interview to recap the test and see what's working, what's not working, and if you have any curiosity about something that happened during the test. But you can also ask additional information before and or after each task, not after the session, but after each task. Or you can also ask information before or after a meaningful group of tasks. So each of these moments has very specific characteristics. So before or after the test, you have more time, more liberty, more freedom to ask questions. You can ask also many questions before and after the test. Before and or after each task is always better to keep the additional information requested a very, very minimum, like 1 or 2 questions maximum, and before or after a meaningful group of tasks, it's something in the middle. So it could be a little bit more than 1 or 2, but not as many questions like after, before, or after the test. This is because you don't want to interrupt the flow of the session of the test too much, because every time you interrupt the user with some questions that are not related with the task at hand, not with the user interface at hand, then the person needs to go back into the context, go back into the flow, and this can add cognitive difficulties, and can slow down things, and can reduce the success of the subsequent task for tiredness, for instance. Then you have to select which equipment you will need according to the criteria, according to the methodology, according to the task you define. So, like, for instance, you want to video record everything, you want to audio record everything, you need the task on a piece of paper because you want to give the task to the participants in a written format, etc., etc. And finally, you also need to prepare an informed consent form for participant to fill, something very similar to what you did for the interviews at the beginning. So the consent, explicit consent to participation. If you decide to have post-test, post-session questionnaire, you can also have, you have typically them in a debriefing session at the end of the test for each participant individually, one at a time, after their own session, and you can ask a general and specific question to better understand some pathway or comments or things that happen, or maybe things that all participants did in a certain way, and maybe one participant did not, and so you want to ask this specific participant something about their actions, their motivation, because you notice a difference between this single participant and everyone else. All this decision needs to be written down, and also been written down in a written test protocol that's called typically script for consistency among sessions. This script contains the step-by-step instruction with all the needed questions and forms that you need to deliver to the participants. Often, this script is down to the exact word that the facilitator will say, so that the facilitator will give the same identical information, word by word, syllab by syllab, to every participant. So you have absolute consistency in information that you give to all the participants without minimizing the difference and minimizing the possibility that you give more information to one or fewer information to the other. The appendix of this test protocol may also contain a table with all the tasks and the metrics and the things you have decided before that I talked in the previous slide. After you did all this, you can also practice your script. It's recommended that you practice your script, especially the exact wording that you are going to say, with friends or colleagues, so that if there is something that is unclear, some steps that are not well connected, etc., you discover them. You can find bugs in a way, you can fix them, so that you don't waste your time, but also your user time, your participant time. Because if you waste a participant, you have to discard the entire results of that participant and recruit a new one. So it's always better not to. So participants, we talk a lot about participants when we talk about need finding. Some additional point here. Participants should be a realistic user of the product or service or application that is being evaluated. They could be someone that already used the system, or they could be similar to the target user group. Participants should represent, of course, the intended user community, so the target group, with attention to background in computing and experience with the task. You don't want super expert only, or you don't want super novices as well. You probably want to balance both in some way, and also motivation, education, and ability with the natural language used in an interface. So again, if it's your specific target population, it's obviously better because you have all the knowledge that you need there. The facilitator instead guides the participants through the test process, to the session, to each session, and give instruction, answer any participant's question, and can ask also follow-up question at the end of the session. The facilitator, most important, must not influence the participant behavior. Is there to facilitate, is there to guide, but then introduce the session, introduce the task, give the task to the user, and then shut up until the task is done or until the participant has any question for them. And then start talking when there is the need to guide the participant towards the next step, the next task. As I was saying before, there can be dedicated figures serving our observer that are just focusing on observing participants, taking notes, etc., without interacting with any participants. About the consent form, we already briefly spoke about it when we talk about the interviews, but in this case it could be a little bit more precise because, of course, professional ethics practice is to ask all participants to read, understand, and sign, so to be explicit consent, a statement that say these 5 things. First, I have freely volunteered to participate in this experiment, in this testing, in this evaluation. Second, I've been informed in advance what my task will be and what procedure will be followed. Third, I've been given the opportunity to ask any question, any clarification, and I've had my question answered to my satisfaction. Fourth, I'm aware that I have the right to withdraw consent and to discontinue participation at any time without prejudice for my future treatment. So our participants can in any moment say, well, I changed my mind, I don't want to continue with the test, and you have to discard all the information, all the data that you collected up to that point for that participants. Finally, my signature below may be taken as an affirmation of all the above statement, and it was given prior to my participation in this study. So the first thing, after explaining what the session, the testing is about, is to have the informed consent form filled out and accepted, explicitly accepted. After that, you can start with the first task. Tasks. Tasks needs to be defined according to the main goals that the user may have on your system, on your application. So in our case, you already have 3 tasks. If you remember, we have simple, a moderate, and complex task. So the task for the usability testing typically are subtasks of those 3 tasks. So that's why I told you before that there should be typically there are 5 to 10 tasks, because you have 3 in this case tasks, and from those you have to define some subtask or related task to explore what you implemented. But since what you implemented, what you created is based on the 3 tasks, it should not be very difficult to do that. So again, in this specific case, as I told you before, a task can be anticipated by a scenario. So rather than simply saying do X with no explanation, most of the time it's better to situate the request with a short scenario. So something that sets the stage for the action and explain why the person needs to do X. And a task scenario for usability testing needs to provide a context so the people can engage with the interface and pretend to perform it as they were in the real world context, be at home or in the office or around in the world. Tasks should be realistic and actionable, and concrete also, I said before, and should avoid giving clue and describing the steps. So, example of realistic task. Let's say that our goal in the interface is to browse product offering and then purchase an item. This could be similar to your simple, medium, or moderate or complex task. A poor task for the usability testing is purchase a pair of orange Nike running shoes. A better task could be instead buy a pair of shoes for less than $40. Why this is a better task? First, because it's more realistic. If you go, like in this case, in a multi-brand online store or in an application, you probably want to look for shoes with a specific target price, more than looking for a Nike running shoes that are orange and I don't care about the price, the size, etc. So other factors could be more important than the color and brand. Not always, but it can be. And also, if you imagine an interface like be Amazon or something like that, and where you want to purchase a pair of orange Nike running shoes, you can maybe filter for running shoes, filter by Nike, and then you have to scroll all of them to look for an orange. That seems, it's not a terrible task, it's just a poor task, because this seems artificial. You're just looking for something that is orange within this category without, again, looking at the price, looking at the sizes of the shoes, etc. Why better? The other one is a better task, because there are, first of all, you still have some freedom on selecting the shoes, but the particular things is that you won't spend no more than $40. So you can have maybe some filtering, some ordering that you can use, and so you can observe the user maybe using this filtering, this ordering, or if the user is going just to scroll down and look for one random pair of shoes that is less than $40. So that should be realistic. That should be also actionable. So let's say that your goal is find movies and showtime. A poor task could be you want to see a movie Sunday afternoon, go to fandango.com and tell me where you will click next. A better task instead is use fandango.com, and then you have to figure out how to use fandango.com. That is, go to, open the browser and go to, probably, but use it to find a movie you will be interested in seeing on Sunday afternoon. Very similar. The second one is more actionable. It's not saying step by step what you want to do first. And second is not a task that tell you, it's not a task that you go on the website and then you have to say the facilitator where to click by explaining, but it's a task where you do something. You use fandango.com to find a movie you will be interested in, so there is also personal drive in this, and you click on the movie, because to find a movie you're interested, you click on the movie, you open the movie, whatever is possible to be done on fandango.com, but that movie should be available on Sunday afternoon. It cannot be a movie that is that you are interested in but is on Monday only. Avoiding, also in defining the task for usability testing, you have to avoid giving clues and describing the steps. So again, if the goal is look up grades, imagine grades for students, the poor task is you want to see the results of your exams, go to the website, sign in, and tell me where you would click to get your transcript. That's a terrible task, because it describes you what you need to do. So of course, the chance for error is minimal here, because you are telling go to the website, then log in, and then tell me, so this is again not actionable, where you would click next to get your transcript. Again, a better task is look up for the results of your exam. Of course you have to go on the website, of course you have to log in, but I want to see how difficult it is to get to the results, to open the results page of the exam. So avoid giving clue, avoiding describing the step, make the task realistic for the person. A movie you will be interested in, a pair of shoes less than $40, a pair of shoes less than $40 and size 7, etc., and avoid and make it actionable as well. Actionable, realistic, no clues, no absolutely describing the steps. But describing steps are not tasks, as you can remember. After defining the task, you have to also define metrics. For instance, metrics for success or failures criteria for the task and for additional information. You can ask two kinds of metrics. You can ask subjective metrics, like question you ask participant for, like background information, age, completed studies, etc. You can ask subjective metrics after each task scenario is completed, such as how easy it was, the task, or satisfactory for the task, etc. And you can also ask about the overall ease of use, satisfaction, and likelihood to use, recommend the same application to others. And these are subjective because it's an opinion, in a way, of people. How I found the task. It's my opinion, it's my perception of. And then you can also have quantitative metrics, that is what you are measuring in your test, like successful completion rate, error rates, time on task. So number that say the participant took 1 minute to complete the task. That's not subjective, that's 1 minute. And you can then collect this information all together to understand, for instance, if there are tasks that should not be so long to be completed. And here there is a table that reports some of the most common quantitative metrics that are used with the value that you typically use. So we have typically successful task completion that say whether a task is completed or not. So if a task is completed, means that the participants have found the answer or completed the task goal according to their opinion. And this could be Boolean, true, false, is successfully complete or not. Or it could be also on a scale between 0 and 100 or 0 and 10, in case you want to say that this task maybe has been completed, but with some minor error that doesn't prevent the completion of the task. For instance, let's say that the task is book a room for tomorrow in Politecnico for 100 people. And let's say that the participant book a room in Politecnico for 100 people, but not tomorrow, in 2 days, or today, and said the task is complete. Is this task complete or not? Well, if you use a Boolean value, you probably can say no, it's not complete, because the task was a room in Politecnico, yes, done. A room 100 people, yes, done. A room tomorrow, and that's of course not done. But if instead you use a scale between 0 or 100 or 0 to 10, you can say, well, if the user missed the date for whatever reason, maybe the person, and you can see it because you're observing what's happening, and maybe the person click on the proper date tomorrow, but then forget to click OK and just close the calendar with an X, and that was saved as today, as the current day, and not at the selected day. That could be still completed because the task overall was completed, the goal of the task was successfully achieved, but it was a slip, a small error that would impact on this percentage. This, of course, is very much dependent on your decision and very much dependent on the kind of task you are going to use. These kind of errors are non-critical errors that are reported below. So a task, you can consider a task still successful complete with 90 out of 100 scale or 9 out of 10 scale with some non-critical errors. You cannot with critical errors, because critical errors are deviation at completion from the target of the task, so that the participant cannot finish the task. And participant may or may not be aware that the task goal is incorrect or incomplete. So the task is X, the participant do Y and tell you I've done. So of course the task is not completed, and in saying I'm done, this person could have done one or more errors with the interface that deviate from the task. And that could be an absolute, like 1, 2, 3, 4, or a relative number, like in percentage. Then you have non-critical errors. Non-critical errors are errors that are recovered by the participants and do not result in the participant's ability to successfully complete the task. These errors result in the task being completed less efficiently. So let me use, and again, this could be an absolute number, a relative number, or they may affect the successful task completion. So let's say that, let's put the example as before. I want to book a room in Politecnico for 100 people tomorrow, and I select today, everything right except today. And then I say task completed to the facilitator, and I say, no, wait a minute, I was wrong, I didn't select tomorrow, let me fix it. So this brings the task C successfully completed, but there was one non-critical error, so that the person selected today instead of tomorrow. That is a non-critical error in which the participant ability to successfully complete the task is still there, and is recovered because the participants say, wait a minute, I made a mistake, and that could be a non-critical error. And then you have the error-free rate, that is the percentage of participants who completed the task without any error, and it's a relative number. You can also have time on task, that is the amount of time that it takes to a single participant to complete a single task. You can also have a subjective measure on Likert scale, like self-reported rating for satisfaction, ease of use, etc. And you can have also free text or free voice in this case, likes, dislike, and recommendations. So questions about what the participants like the most, like the least, any recommendation for improving, any discussion, typically at the end of the session, or a minimum or after a meaningful part of the session itself. These are all possible metrics. You don't have to have all these metrics in a test, but you can decide, for instance, that you want a successful task completion and keep track of critical and non-critical errors, or I want task completion, critical error, and time on task. So you can pick metrics from this table and use them according to your goal, according to what you want to observe, according to your specific task. In addition to these metrics, there are reliable and validated questionnaires for subjective measure and open question that I'm going to introduce to you and that you can use if you want. Of course, measuring success, so task success or completion, is one of the most common metrics used in usability testing. Again, in a simple form, it's a binary metric, and we can define several levels of success, as we're saying, depending on the relative system and task. So here there is an example. An example is more concrete than before. Again, booking the room. Complete success, the user booked the room with an error, as specified. Success with one minor issue, with non-critical error. The user booked the room but selected a wrong size or a wrong date. Success with a major failure. The user booked the room but entered the wrong date or amount of time. Because in this case, the size is less important than the date or the time. I mean, if people can maybe stand for a while, if the size is wrong, or if the size is too big, doesn't matter, it will fill half the room. But if you select the wrong date or the wrong amount of time, that will be not easy to solve. And the failure instead is the user is not able to book the room at all. And then here there is an example of the level. No? with some numbers and of distribution, like complete success is 20 user, minor issue 35 user, major issue 30 users, and failure 15. In this case was placing an order. So 20 participants out of 100 were able to complete the task with no error. 35% placed an order but had a minor issue like before, size of the room. Major issue 30% and 15 not able to place the order at all. Now let's have a look at some methodology. I'm going to present two methodology, the think aloud and the cooperative evaluation. These are very similar, they're very, let's say, related methodology. Think aloud is a methodology that asks the participants to talk while they are thinking. So while the participants perform a task, she is also asked to describe what she's doing and why, what she thinks is happening, etc. So it will be something like this. I'm going now to click the button that say this because I think that to complete the task I need to go in this section, and then once I am in the section I'm going to scroll down and I'm going to read here, and reading here I can notice that there is a link, and then I'm clicking on the link, etc. So this is about the think aloud. So thinking what you are saying just in a way that is allowed, so that others can know, facilitator can know, and can listen. Advantages is very simple, of course. It requires little expertise. Everyone is able to talk while they are doing things and giving voice to their thought. Advantages, it's also they can provide useful insight because you understand what the user is doing, why they're clicking, why they're moving one page or another, etc. And can also show how the system is actually used. The disadvantage is that it's highly subjective, is highly selective, and also the act of describing what the person is doing might alter task performance. So for instance, if you use the time on task as a metric, that time on task is not significant with think aloud, and so should not be used with the task with think aloud, because of course the act of verbalizing the thought has an impact, has an implication on the time that you spend doing the task. So those time is not anymore significant for the task, because the task without think aloud would have been probably a different amount of time, probably shorter amount of time spent. Cooperative evaluation is actually very close to think aloud, is indeed a variation of think aloud. Is very similar, it's done in the same way, but the participant and the facilitator with the cooperative evaluation collaborate during the evaluation. So the participants think aloud as before, but can also ask question to the facilitator. The facilitator also reason with the participants, and they together ask each other question throughout and collaborate during the evaluation during a specific task. The additional advantage on think aloud is that cooperative evaluation is less constrained and even easier to use, because you have a partner, a peer, that helps you in navigating the system and understanding. User in this case is also encouraged to criticize the system because it's more a conversation, and also clarification is possible because the facilitator is there and talk with the participant without any problem. Again, metrics can be affected by cooperative evaluation. And again, when you want to use one of these methodology, you can use one of them for a single task, for a couple of tasks, but you don't have to use all of them for all the tasks. So pick the task where you are curious about understanding what's going on in the head of a person, or task where you want to go deep into the task that is carried out. Do not try to use this methodology on all the tasks just randomly, or saying let's apply think aloud to everything, because there are tasks that make sense for think aloud and there are tasks that you don't really need to discover very much from think aloud and can be done without it. After methodology, you also have to think a little bit about equipment, and any of these things can work for an effective usability testing, starting from the usability testing lab, as we have seen before. You can also have a room with portable recording equipment, a room with no recording equipment, but someone is observing and taking notes, so you can skip the recording because you have multiple people observing and taking notes. And also you can have remotely with participants in a different location that is either moderated or unmoderated. Material. Which material you can use? You can use, of course, paper and pencil. You can use audio, especially good if you want to record think aloud. You can also use video recording that is accurate and realistic. You need to rewatch the entire video. The video, of course, needs special equipment and may be obtrusive to place a camera in front of the user or watching what the user is doing on the screen. You can also screen record the screen if you want to have an approximation of the video. You don't see the participants, but you see what's going on, what the person is doing on the screen. You can have also, this is pretty typical, to have computer logging. So the application that is recording what they are doing, what it's doing. Like when I click a button, I save on a file the timestamp in which I click that button, and when I click another button, I will also save the timestamp of this other click. And so at the end, I have a log of all, the clicking around the application in order how they happen, and with the information which button was clicked, which link was clicked, and so I can see if there was back and forth, etc., how many times it was back and forth, how many times a button was clicked, etc., etc., etc. Of course, you can have large amount of data in this case that could be difficult then to analyze. Or you can also have eye tracking, that is a specific device to track and record eye movement. In practice of all this material, there is a mixed use. Audio video transcription is difficult and requires skill, and some automatic support tool can be available to ease the usage of this tool. Then, I told you before that you can have questionnaires, a reliable questionnaire you can use, and you can use questionnaire after a task or after the session or after meaningful group of tasks. So after a single task, one reliable and existing and sort of standard questionnaire is the SEQ. SEQ stands for Single Is Question, and as the name say, it's one question of an Likert scale from 1 to 7. From 1 is very difficult to 7 is very easy, and the question is overall, the task was. So post-task questionnaire needs to be short, as I was saying before, 1 to 3 questions, to interfere as little as possible with the flow of the person using the system in a session. And this kind of questionnaire exemplified very well in a simple manner. It's a single question that is experimentally validated, is reliable, valid, and sensitive. So this is a questionnaire. If you want to use post-task questionnaire, you can use this question instead of imagining a new question, because it's experimentally validated. So the results from this are something you can rely on and say, okay, this is all the participants said very easy. This was not by chance, but is actually a good probability that is actually very easy for real. If we move from post-task to post-test questionnaire, probably the most famous standard post-test questionnaire is SUS. SUS stands for System Usability Scale, and it was invented in 1986, so it's not really young as a questionnaire, but also means that it has been used for almost 40 years now, and so it's reliable, is well done, is well used, is well studied. So it's a strong candidate for a post-test questionnaire. The inventor, John Brooke, defined it a quick and dirt but trustable usability scale. And pay attention, it measures the perceived usability of a system. So not necessarily the real usability of the system, but the usability of the system that is perceived by the participant. So it's a subjective questionnaire, give us subjective results in a way. The questionnaire that you can see here in the slide is a 10-item Likert questionnaire from 1 to 5. Each question has 5 response options. And the results of this questionnaire is that produce a score from 0 to 100, which is unfortunately not equivalent to a percentage score. It's just number 0 to 100. You cannot say is 90%, it's just 90. In general, a SUS score above 68 is considered that the system, the usability, the perceived usability of the system is above average. So 68 is like sufficient, above average. The higher, the better, the lower, the worst. SAS has 10 questions, and that are like this. You can also find it on the web without any problem. And you can notice that these questions are always one positive sentence. I think that they would like to use the system. I thought the system was easy to use. I found the various functions well integrated, etc. So 1, 3, 5, 7, 9 are positive, and 2, 4, 6, 8, and 10 are instead negative. I found the system complex. I think that it would need support to be able to use the system. I thought there was too much inconsistency in the system. This is done on purpose. So 1 positive, 1 negative, 1 positive, 1 negative, etc. with the same scale. Because to calculate a score, to calculate that 68 above average, you have to do the same. Each answer is 1 to 5, and the one you selected is the number. For every odd number question, subtract 1 from the score. So if the answer of question 1 is 4, the score is 3. 4 minus 1. For every even number question, so for the negative question, subtract the score from 5. So if the answer of the question is 2 is 4, so the score is 5 minus 4, 1. And then sum the score from the resulting number, so 3 plus 1 plus etc., and multiply the total by 2.5. If you do this, you calculate the score that, again, if it's above 68, is above average. Advantages. It's reliable. The score reliability has been evaluated over decades, almost 40 years now, and it's on par with more complex and costly method and questionnaire. It's also free, quick, and simple. Just 10 questions, 5 points per question. It's also quite used in industry, so people in industry know about the SUS scale, and it's applicable to a wide range of technology, system, or product because sentences are quite general. Disadvantages is subjective. It's a subjective measure of perceived usability, so it should not be your only method to evaluate the user interface in the usability testing. It gives no clue about how to improve the score. So if you get a score of 85, good, but how can move from 85 to 100? Who knows? The questionnaire will not give you anything to know this. So it's not diagnostic. And the other disadvantage is that it's not possible to make comparison between the two systems and their functionality using SUS. So you cannot say, my map application get 70 and your map application get 68. So my map application is better than yours. You just cannot. You cannot compare the 70 of one application with the 68 of the other. That just means, say, that one application is perceived with a usability that is perceived slightly above the average, while the other that gets 68 is perceived as above the average. But you cannot say that one is better than the other, because it's just a subjective measure of perceived usability and is not comparable within other systems. Another questionnaire, post-test, that exists is the NESA TLX, that stands for NESA Task Load Index. And as the name says, is a questionnaire that was born for NASA, was created by NASA. And as you can see here, is looking for various kind of demand, human demand, mental demand, physical demand, temporal demand, performance, effort, and frustration. So different from SUS is not about perceived disability, is more about how difficult, in many sense, was to perform a specific task. And this questionnaire exists since 1980, in the 80s, so again, another things that are more than 40 years. And it's an instrument still used in NASA for measuring the perceived, not disability, but the perceived workload required by the complex, high technical task of aerospace crew member. So this question is still very much used for complex product and task in high consequence environment, like in the aerospace, like in military, but also in healthcare, where some application, complex application, cannot have too much mental demand, cannot too much physical demand, and too much temporal demand, because otherwise they would be draining for the person using it. They can make errors, and errors in healthcare can also mean risking the life of people. This questionnaire has 6 questions on an unlabeled 21-point scale that is ranged from very low and very high, and each question addresses one dimension of perceived workload, as I said before. And then respondent weight each one of the questions pertaining to the 6 category to indicate which matter most to what they were doing in that moment. So it's more, the physical demand is more important than the mental demand in this task, or the performance, or the effort. So which is the relative weight of these categories according to the task, to the workload at hand. How to compute the score? It's complex. It's a complex instrument to score. It's not simple as for the SUS score, and you can either download instruction to compute the score from the NASA website, or there is a free iOS application to compute the score given the input of the results. And then we said that in usability testing you also have scripts, and here there is simple usability testing script. You can download them and have a look at them. Just a notice, they are not complete in terms of task, but just give an idea of the script you can write, like the one word-to-word script you can write. And we are going again to do an exercise on this in the next 3 hours of the course. So this could serve an example, but we are going to also create our own example of the protocol and script for the entire usability testing. So all of this is for planning. So all these things, methodology, equipment, material, participants, who does task, etc., serve for planning. So after you plan, you have to run. So how to run the usability testing? First, as I said before, you need to get the informed consent. It's better in written format, and it should be explicitly done. Then one person acts as a facilitator, and the rest of the team, in our case, are observer, and at least one of the observer must take note. And at the beginning of the task, be sure to tell participants that we are testing our application, we are testing our system, we are not testing you. Any mistakes are not your fault, but the application fault. So all the mistakes are, as we said at the beginning of the course, and we are circling back, the application fault, the system fault, the computer fault, not the person, the participant fault that makes mistakes. The facilitator should always follow the script during the running, remaining neutral, not helping the participants, and provide clear instruction. And tasks can be given in a written format, one at a time, or vocally, still one at a time. The facilitator must encourage participants to adopt and explain how to use it, the chosen methodology at the right moment for the proper task. For instance, how the thing out work and which task to use it for. The note takers takes notes, what the behavior, the comments, the error, completion, success or failure of each task, etc., etc. And the system should be ready to measure all the defined criteria in the planning phase. And then after running each session, if you have 5 participants, you will have 5 sessions. Let's say you also have the briefing, so you have additional questions, you have additional notes at the end of each of these 5 sessions, for instance. You can analyze. You can analyze the collected data to find failure in the user interface and ways to improve. And you can start from the written notes, you can start from the audio recording, from the video recording, from the log that the system is maintaining, etc. Don't forget to consider the collected metrics per task and overall, which mean then if I collecting the success rate per task, I can say task number 1 as across 5 participants as being completed successfully 4 times and 1 time was not completed. Task number 2 has been completed successfully 5 times, so no one had problem, etc., etc. So per task and overall. Quantitative data can be summarized as well and put together. So overall, the success rate among all the tasks is 80%. And you can also look for trends and keep account of problems that occurred across participants. As I was saying before, you notice one participant doing something unexpected, and then you have the second participant doing the same thing unexpected, and that could be a question for you to ask in the debriefing session to understand why the first 2 participants did the same thing unexpectedly. And then if also the third person does that, then it's of course a trend and there is something that the interface is not communicating properly. If everyone has this unexpected behavior. So you can take a note of observation about pathway, participant took, comments, a recommendation, but also answer to any open-ended question you're going to ask. Okay, so with this close the actual last theoretical lecture of the course. In the next class, we are going to talk about assignment 5. We're going to talk about how to implement your application, your prototype in high fidelity, so for assignment 5. And as I was saying before, we're also going to do 3 hours of exercise on usability testing. The labs will continue until the end of the course as well, and they will be starting from next week, devoted entirely to assignment 5, that is implementation of the high fidelity prototype and usability testing. And assignment 5, as I will tell you next week, is due 7 days before the exam. And with that, thank you and see you next time.